Welcome to the last and final part, the fifth part of my intermediate instrument flying series. My name is Vikas and I'm a commercial pilot, multi-engine and single-engine instrument rated. So we have learned about radial interceptions, DME arcs, course reversals, basics of holds. Now, in this video, we'll be talking about ILS approaches. I hope you already know how ILS system works so that I don't have to mention that. If required, put it down in the comments and I'll make another video for it. So once you know how it works, we're going to see how it looks on our instruments, how you fly a ILS approach. Now, before we go into the ILS approach, you need to know what I've taught in the previous videos, because to join the final approach, you need to do the previous procedures. And in the end of this video, we'll look at different charts published by FAA for America, obviously, to fly a certain procedure, a full procedure with the previous parts coming down to a ILS or a VOR approach. Okay, that's the objective of today's video. So we're consolidating all our gained knowledge into one video. So let's start off. So you already know what an ILS is, right? So there is a runway and there is an ILS system installed, which projects radio waves in a certain direction, giving you a glide path. That is your vertical guidance. In the same way, it's installed and gives you horizontal guidance as well. So you have to stay within this vertical glide path to have a proper descent rate. And you have to stay within this horizontal guidance so you land in the correct direction and you don't go off the runway. Remember, it's instrument flying, so you are not able to see the ground. You're just looking at your instruments while flying. You know, ILS has vertical and horizontal guidance. Now, looking at our HSI, how would this look, right? So again, tune your proper course. In case you tune the opposite direction of whatever runway you're landing at, it becomes a course reversal or a back course. That way, your CDI shows the opposite deflections, right? There are procedures where you will use the localizer of the opposite runway to land on a certain runway. That is a back course procedures. We will look at the example of that as well. For now, we are looking at a straight-in ILS approach, right? So you have tuned the proper course and your CDI is either towards the left or the right or the center, and your deflections are here, right? So the main objective is to keep your CDI centered and main objective is to keep the CDI centered. That means you have horizontal guide. If the CDI starts moving towards the left, you make correction towards the left by turning towards the left. And if it moves towards the right, you make corrections by turning towards the right. That's your CDI. And talking about the glide slope, it either moves up or down, right? It has to be in the center. If it moves up, it means you're too low. In case it moves down, it means you're too high. So you always need to keep it in the center. Again, follow the same thing, follow the needle. In case the glide slope goes down, pitch down to intercept the glide slope, you're too high. In case the glide slope goes up, pitch up to intercept the glide slope so that you're too low. What you always have to keep it in this position, your CDI centered and your glide slope on the center dot, right? Now, you do this by changing, obviously, you turn the aircraft by banking or by pitching for the glide slope. When you're doing this, always remember to make correct adjustments to the power. You should not change your airspeed on your final approach. If you change, you could stall the plane, and stalling on final approach means you're going into the ground. It's very dangerous. So make sure you make proper adjustments to the power when you're making adjustments to the glide slope and even to the CDI in case you're banking too much. Right. Your main objective is to keep it centered. That's it. That's your ILS approach. Right. You can join the final approach. The final path is basically straight. Let me choose a different color. You're just going straight onto the runway at a certain proper glide path, usually 3 degrees. You can change. Right. This is how a ILS looks on your instruments. I hope you know the components of the ILS, like the visual components, the vertical guidance, the horizontal guidance, and all of the other components of the ILS. We'll do a different video on that if you require one. Mention it down in the comments. Right. This is how a ILS approach looks on your instruments, right? Now, let's consolidate everything we have learned in the previous video series and put it together. How do we do this now? Let's go to our trusty old ForeFlight and look at a few charts, and I'll explain how to fly these approaches. Okay. One of my favorite approaches that I did do during my training was Daytona Beach in Florida, USA. Okay. This is a very good example of a DME arc into approach. Great. This is how the plate looks. Don't be daunted by how it looks. I'm not going to ask you questions. I'm not the DPE. I'm here to explain by how it looks. Forget about what all is written in the plate. Let's just concentrate on what the diagram says and how we fly this approach. So, sorry for that. So this is the diagram you need to be making in the sky by flying in the proper directions. We talked about DME arcs. So let's assume that we're coming in for this approach somewhere from the south. Let's say we're somewhere over here, right? So what's the first thing we do in a DME arc? Intercept the radial. So for this, we're intercepting radial 161 degrees from the Ormond Beach VOR at whatever angle. In case you are more than 10, it's 90-degree intercept. Otherwise, it's a 45-degree intercept. So you intercept that radial and start going inbound. Right. You make the 45-degree intercept and start going inbound till what distance? It says 18.9 degrees. Correct. So do you go till 18.9? You don't. You start 0.5 before 18.9. So that will be 18.4 nautical miles. At 18.4 nautical miles, you make the initial turn towards which direction? We are going northbound, right? Your arc is towards the west. So you make an initial 90-degree turn towards the west, right? 161, 90 degrees, 161 is this. 90 degrees, 161 plus 90 degrees would be 251 degrees. So in this position, you should be facing 251 degrees at a distance of 18.9, right, which is already here. Once you've done that, your initial turn is done, right? Next part of the DME arc, we already talked about it. We tune the next radial, as mentioned here, it would be the 179 degrees radial. You make a 90-degree intercept to the 179-degree radial. At this point, what heading do you have to be? 179 plus 90 degrees, that would be 269 degrees. This is your heading, right? And in between, you can have another radial. That's up to your choice to whatever accuracy you want it to be. And then you go on to then continue the procedure. You keep making 90-degree intercepts to the next radial. And the next radial, until you go on to what radial. I told you there's something called as a lead radial. Okay, this radial leads you onto the next part of the approach. Correct. So once you make the 90-degree intercept with 214 degrees radial, 90, 214 plus 90. So at this point, you'll be basically facing 304 degrees, right? You have intercepted the lead radial. Now, you have to move on to the next part of the approach. The next part of the approach is the ILS part. So you change your frequency from the VOR frequency to Ormond Beach VOR to the localizer frequency, which is IDAB. This is our frequency. You change the frequency and you set your course to 070 degrees, which is your final approach course. Once you have done this, it's as simple as your radial intercept. You just intercept 070 with a 45 degrees, intercept it, center the CDI, and you just start flying inbound. At this point, your heading should be 070 degrees. This is assuming nil wind. There's no wind. If there's wind, you correct towards the left or the right as per the wind. Right. You have established yourself on to the final approach. Okay. So what did we do? We used our DMER skill. We were somewhere else. We used the DMER skill that we learned to align ourselves with the final approach. Once we did that, now we need to fly down. Obviously, if the CDI is moving towards the left or right, you keep making corrections. But now is the ILS part. The ILS is also providing you the vertical guidance. You follow the glide path and descend down the ILS onto the runway. That's it. We are using our different instrument skills to make an instrument procedure work. Right. So you need to know to fly this procedure, you need to know DME arcs and ILS. Okay. If you guys want to know how to read these charts or the IKO charts or the Jepson charts, leave comments down below and I'll make videos about it. Okay. This is a perfect example for a DME arc into a ILS approach. Now, let's look at other skills we have learned. Another very good example, Melbourne International Airport in Florida. Let's look at ILS localizer, liner, right. Okay. Now, in this approach, we're going to talk about course reversals. Okay. Imagine you're somewhere over here and you're flying towards the airport. You can't see the runway and you can't you don't want to land on the opposite runway and crash with someone. So you do the course reversal procedure, which we talked about. You fly straight to the Melbourne VOR. This is our frequency. And once you're over the Melbourne VOR, you start flying outbound on the radial. What's the radial? The course is 094, but the radial is 274 degrees. You start flying outbound on 274 degree radial. Okay, for how long? We did talk about this, right? So it says, the chart says, remain within 10 nautical miles. So approximately you will fly out towards 8 nautical miles. Once you've flown to the 8 nautical mile point, once you've done that, you make the procedure turn. It's clearly written over here. It's as simple as that. Forget your CDI. When you're flying outbound, remember, you're in the back course. So your CDI deflections will be in the opposite direction. When you're going in this direction. But once you've done that, so if your deflection is towards the right, you make correction towards the left. If your deflection is towards the left, you make corrections towards the right. Okay. Once you've flown outbound for 8 nautical miles, you make a turn. Now, just forget your CDI for now. You just look at a heading indicator and you turn to a heading of 229 degrees. Remember, you have to stay within 10 nautical miles. So you fly for approximately 1 nautical mile. Your average distance will be about 9 nautical miles from the VOR, right? Once you've done that, you make your 180-degree turn to heading 049 degrees, as we talked about in the course reversal. Once you've done that, you come back, you change your frequency now. You change it from the Melbourne VOR to your localizer frequency, which is this, IMLB. Right? Change your frequency, set the correct course. You need to be on the course of 094 degrees now. You are on the radial 274, but you have to be on the correct course. Otherwise, it's again back course, you go in the opposite direction, and that could lead to dangerous consequences. Right? Tune the correct course, intercept it just like you would intercept any other radial, and you start flying inbound on the localizer by making correct corrections. If the CDI goes towards the left, you make a turn towards the left. If it goes towards the right, you make a turn towards the right. And then similarly, your vertical guidance is given by your glide slope and you make a landing. Voila, we used our second skill that we learned, course reversals. You were in a very bad position to land towards the north, but you tracked your localizer outbound and made a course reversal, right? Next part. Okay. Let's look at how we can use the next part, which is not this. Let's talk about, see, localizer back course, runway 27 left. Correct, for the same airport. Now, what are we doing here? We are using the localizer for the opposite runway, which is 09er, the same frequency, but we are doing back course. Remember, back course, CDI, opposite deflections. But remember, there's a big but here. Sorry for that. Basically, what it means is your older analog instruments do have this sort of a function, but your newer glass cockpits automatically correct that towards the straightened deflection. So if you have a deflection on your CDI in the glass cockpit, you make the correction towards whatever it's showing. Okay, this is your back course. Okay, we saw how to use TMA arcs, we saw how to use course reversals, and we saw how to do ILS approaches. Now let's talk about holds, right? Let's take another good example, Space Coast Regional. Something's wrong. That shouldn't happen there. Okay. Okay. Yep, there we go. Right. Now, in this hold, in this approach, you see, there is no procedure turn. In case you end up in a situation like this, you're in the south, you're going towards the north. You want to do this approach. How do you join this approach? Your landing runway is here. This is your landing runway. You're in the perfect opposite direction, right? So you do two things, course reversal. But how do you do this? By joining a hold. There is a hold at this fix. This is a GPS approach, but it's works similar to whatever navigate, right? So you fly towards this fix, join into this hold, and continue on the next part of the approach. But just for this example, let's talk about what sort of entry we do into this hold. what sort of entry we do into this hold to be end up in the correct position, right? Just for example, we can do multiple problems in this in the upcoming videos if you do want me to teach you how to figure out the entry patterns. So you go into the fix. Let's say we're flying a heading of approximately 0 to 0 degrees, okay? And the outbound leg, what did I say? You need to have importance on the outbound leg. That is 319 degrees, right? So how would this look on your instrument? The instrument is like this. 020 degrees is over here, okay, on top. And your outbound would be, this is like this, right? Your CDI is left or right. Let's not bother about that for now. And your outbound is 319 degrees. So it's somewhere over here, correct? And the hold is a standard right hand hold, correct? So the pencil model, what I taught you, you lift your pencil 20 degrees on the right side. So I do that 20 degrees over here. I have 3 zones, 1, 2, and 3. We see our outbound lies in the second zone, the second biggest zone, which is a parallel entry, right? This is how you identify the holes, by looking just at your instruments and using your pencil or your hand, just for practice. Over time, you just look at the instrument and tell you, it comes with practice. Right, so it's a parallel entry. How do we fly this entry then? So you go towards the fix, fly over the fix, then outbound, I mean opposite direction on the inbound leg, it's 139. So you'll be flying a heading of 319 while being on the inbound leg, keeping your CDI centered for 4 nautical miles. Once you've done that, you make the procedure turn to come back and intercept the inbound leg. That's how you join the hold. You've joined the hold, then you can continue on to your approach or maybe have some laps in the hold, whatever instructed by ATC. And that's how you use your instrument skills in joining different sorts of holds. And that's the end of the video series. If you need whatever other things, how to read these charts or how to read approach plates or how to read IFR charts, you can leave a comment down below and I'll make series on those as well. Thank you for joining in for the entire series. It's been a pleasure and good day.